Hey, what's up everyone? Today we'll be moving from circular functions into complex numbers, which should be chapter 4 in your textbook. The hard questions relating to complex numbers often involve factorizing your complex polynomials into its linear factors. But an even harder question is when you don't even know the full complex polynomial. So we'll have a look into that today. Keep watching and you'll find out. One example of such question is this question right here. The polynomial, you got the equation where a and b are real numbers. So we don't know what a and b is, we just know that they're real numbers. Has 2 minus I as one of its zeros. So zero, another word for zero is root. You might be more familiar with that. That just means if I sub in 2 minus I over here into every z value, I would get a 0. So that's why it's called zeros, or sometimes it will be called root. Then we want to determine the solution to the equation pz equals 0. That means we're trying to solve for z values that will give pz equals to 0. How do we find that? Well, the first problem here is we don't even know what a and b is. You can maybe try long divide or any other kind of example, but you'll quickly find out that long dividing 2z cubed plus az squared plus bz plus 5 by the factor, so z minus 2 plus I, you'll find it quickly that this is it's going to be a very hard challenge. It's pretty much very difficult to do, and it'll waste a lot of your time. What you can actually do to find a and b is you have to take advantage of the conjugate root theorem. So the conjugate root theorem, what that means, conjugate root theorem, what that means is if you've got one factor, in this case z minus 2 plus I, and it's a non-real factor, meaning it has this imaginary number, then another factor, as long as your equation, your expression has all real coefficients, so 2, a, b, and 5, they're all real coefficients, they don't have imaginary numbers in them, I, then you can use this conjugate theorem to get your other factor easily. So that's z minus 2 minus I, finding the conjugate of the z minus 2 plus I, so the original factor. You can use the conjugate root theorem, find its conjugate, and that's another factor. So over here we have two factors already. What you want to do is you want to expand this. So we'll do some expanding. Z times z, z squared, 2z, so just go along this way, minus iz minus 2z, and we've got plus 4 plus 2I plus iz over here, iz minus 2I, yes, just expand it, and we have minus I squared. So I times negative I is minus negative I squared. I squared is negative 1, so negative of negative 1 gives us plus 1. And then at the end you have z squared. You can't simplify that further. We have minus 2z. We also have another minus 2z over here. So that gives us negative 4z. iz cancels out with this iz. And this 2i cancels out with this negative 2i. At the end of the day we have 4 plus 1, 5. So we have a quadratic equation, quadratic factor, z squared minus 4z plus 5. Well, we need to find another factor, right? This is a cubic equation, so it must have 3 factors. We've got 2, and the quadratic factor, if you combine these two, is z squared minus 4z plus 5. Now what would you do here? You can long divide, but once again, you have a and b, we don't know what that is. Long dividing this expression by the quadratic factor still would be quite difficult. What you can actually do is you can equate these two together. And if we write z squared minus 4z plus 5, now my other factor, I don't know what the other factor is, so you can write as anything that, well, hopefully doesn't have a or b, so you can write cz plus d, right? So my other factor has to be a linear factor. It can't be a quadratic or cubic factor. It's not possible because our maximum is 3 factors. We've already got 2, so we need only another one. And you can equate that to 2z cubed plus az squared plus bz plus 5. Right, you multiply it out and we'll see why this is such a good way to solve for a and b. Z squared times cz gives you cz cubed. Z squared times d is just dz squared. Negative 4z times cz is negative 4cz squared. Negative 4z plus d is, whoops, we get a minus 4dz. And of course 5 times 5zz times cz is 5cz, and we have 5d. Okay, now I'm equating it once again, same thing, keep the right side the same. We have plus 5 here. Okay, now what do? Look at this. We have c. The coefficient in front of z cubed is c. The coefficient in front of z cubed is 2. So we can reasonably conclude that c equals to 2 because you have no other z cube here, and the coefficient for that z cube is 2, meaning that c has to be 2 or else they wouldn't equal each other. Right, now what can we do? We want to find a and b, right? So let's solve for what d is first. If you combine this, so we know that c is 2. If you combine the z squared together, so I'm going to combine it here, dz squared and minus 4cz squared, those are the only z squared, that should equal your a. And of course, if you combine the minus 4dz and the 5cz, that should equal your b. Then lastly, if you combine your 5d and 5, you should get what d is. So in this case, if 5d equals to 5, d should equals to 1. Right, so we know what c is, 2. We know what d is, which is 1. We can now solve for a and b. Let's look at our red part, the part where we circle red. We know that dz squared minus 4z squared equals to a. You can take out the z squared, so you end up with d minus 4c equals to a. Well, to find a, you know what c is, you know what d is, so just sub that in. 1 minus 4 times 2 equals to a. That means a is negative 7. 1 minus 8 is negative 7. That's pretty good. We found our a. Now we just need to find our b. Well, same thing. You apply the same process, same method for b. Negative 4d plus 5c. You can take out the z because both sides already have z equals to b. Right, well, 4d is just 1. Negative 4 times d is negative 4. 5 times c, 5 times 2 is 10. So I should write 10 over here. And we have b, and that should give us 6. Right, a equals negative 7, b equals to 6. Beautiful. Our final expression, our actual expression would then be 2z cubed. So pz, using our newly found a and b value, should give us 2z cubed minus 7. So this equation right here, that used to be an a, now we have a negative 7 in place of that. Same thing with the b, plus 6z and plus 5. Okay, now the question asks us for the solution to the equation pz equals 0. Now this step is not that much different. So the next step would be, we want to find the solution, right? We know that z squared minus 4z plus 5 and cz, so c would be times cz plus d. That would give us pz, right? And we just want pz to be equals to 0. How would you solve for that? Well, do you know what the value of c and d is? Yes, we do. We already did that. C is 2 and d is 1. Equals pz, we just want that equals to 0. So now all you have to do is just solve for z. Well, convert this into your linear factors. We know what those are. That's your original. Z minus 2 plus I, z minus 2 minus I. So z minus 2 minus I, z minus 2 plus I, times by 2z plus 1 equals to 0. You don't even have to find your a or b values to even solve this. You just have to find your c and d. But the a and b, I just wanted to show you guys that if the question asks you for a and b, you can solve it. If not, You don't even need it, you just need C and D. So to solve for your zeros or your root, well, just z minus 2 minus I equals 0, so z is 2 plus I. We also have 2 minus I, the conjugate. And lastly, we have negative half. If you bring 1 to the right side, that's negative 1 divided by 2, z equals negative half. And those are your zeros. And we did this question. Beautiful. Thanks for watching, guys, and I'll see you next week. We will keep going on with complex.